Hello, my lovely friend. Today I come to you with a new problem. Are you ready to do this with me? Okay, first, pause the video and think about it. Okay, let's do it together. Here is a question that says a heavy ball is suspended from a spring. We see here a ball suspended from a spring, and its weight is initially supported. Okay, the ball is then dropped, so it will bounce up and down, goes up and down. The time between successive bounces is called the period of the motion. So if it's the time that it goes up and then down, we call it the period of this motion and varies inversely to the square root of stiffness of the spring. Here, so this time, this period of this motion, okay, inversely proportional to the square root of the stiffness of this spring. Let me write it. That means the period that I showed with the upper letter T, upper case T, is inversely proportion to the square root of stiffness, okay, of this spring. And then it says the period of a spring of a stiffness 100 unit. So the period of a spring of a stiffness 100 unit, that means when my stiffness is 100 unit, is 2 seconds. So I want to say, if I want to convert this proportion to the formula, I say always I have the constant K that I can write it T equals K over square root of S. Why? Because I said the question said T, the period, is inversely proportional to the square root of stiffness. So if I want to disproportional, okay, make it to the formula, I have to put a k that multiply by this proportion. Always k is constant, fixed number. Okay, and in the part it says 100 unit stiffness equals 0.2 seconds. That means 0.2 seconds equals K, I don't know the value of K, 100 units of this stiffness. So right now I can find the K. As I said, K is a constant, fixed number. So K would be the square root of 100, gives me 10. And if I do this cross multiplication, K equals 0.2 times 10 gives me 2. So I find the formula. The formula always is T equals 2 over the square root of S. Now I go to find the answer of part A. Part A says the period of a spring of a stiffness 300 units. So I am gonna find the period, which is I don't know. As I said, I write the formula K over square root of S. And I know K is 2. I don't know the value of T here. Always K is 2. Over stiffness here is 300. So I write square root of 300. If I find the value of it, C would be almost, let me write, almost 0.11 and 5 seconds. I can find the period here is 0.115 seconds. I will go for part B. For part B says the stiffness required for the 0.1 second period. So I say here I have T equals 0.1 seconds. I know K is 2, so I write my formula T equals 2 over square root of S. So I say T equals 0.1. I substitute T 0.1 equals 2 over the square root of S. Okay, I say the square root of S equals 2 over 0.1, so square root of S equals 20. And if I will write here, rise to the power both sides to the power of 2, right? Both sides to the power of 2, so S equals 400 units. We are done here. I hope you really enjoyed. If you enjoyed, subscribe, share with your friend, and stay tuned. I will see you in the next new problem. Bye bye for now.